Hey everyone, and welcome to this explainer. Today we're diving right into the foundational rules of the physical world. Now, we interact with matter literally every single second of our lives, but when you actually stop and look closely at the mechanics governing its states, you'll find some seriously surprising interactions. So let's just dive right in.
Okay, check this out. We typically think of metal as this hard, unyielding material, right? The stuff that builds our bridges and skyscrapers. But what you are seeing here is gallium. It's a solid metal, but it's melting into a shiny little puddle right in the palm of a person's hand.
So you've got to ask yourself, how does a metal just melt in your hand? How can something defined by rigid toughness completely yield to the mild, everyday warmth of human skin? Well, to figure out this rule breaker, we first need to quickly align on the underlying rules of matter itself.
Which brings us to Section 1, Meet Matter.
Simply put, matter is defined as anything that occupies space and has mass. It doesn't matter if we're talking about the solid ground beneath your feet, the water in your glass, or the invisible air you're breathing right now. Every single substance in our universe shares these two exact, non-negotiable properties. It has volume and it has mass.
But, as we just saw with our melting gallium, matter doesn't just stubbornly sit in one single form. Section 2, the three physical states.
You're probably familiar with the big three: solid, liquid, and gas. But here is the crucial takeaway. These states are completely conditional. A substance's physical state isn't some permanent, locked-in identity. It depends entirely on the surrounding conditions, specifically temperature and pressure.
So, what actually divides these states into distinct functional categories? Let's look at Section 3. What makes a fluid?
Think about a solid block of wood. It has a fixed shape and volume. It stays exactly where you put it and does not flow. Liquids and gases, on the other hand, share a really distinct physical trait. They are able to flow. Because they don't hold a rigid shape, you can easily pour or pump them from one container into another. And that gives us a crystal clear scientific definition. A fluid is any gas or liquid that's able to flow. Now, in everyday conversation, we usually just say fluid when we mean liquids, like water or coffee. But chemically speaking, the gases flowing around us in the air every single day, those are fluids too.
So what dictates whether matter acts as a stubborn solid or a flowing fluid? Let's get into Section 4, temperature and pressure.
It's really a direct cause and effect relationship. An increase in temperature causes an expansion in volume, while a decrease in temperature causes it to contract. And while it's true that all three states of matter do this, the effect is vastly more dramatic for gases than it is for solids or liquids. Gases really react to the heat.
Now, imagine physically trying to squash matter. That's pressure. If you try to compress them, gases at a fixed temperature can be easily squashed down just by increasing that pressure. But if you try to crush a solid block, its volume is completely unaffected. It just won't budge. Liquids kind of sit right in the middle, being only slightly compressible.
All right, we've covered mass, volume, flowing fluids, temperature, and pressure. Section 5, comparing the states.
Let's pull all of these threads together, take a step back, and look at the ultimate scorecard to see exactly how these states compare structurally.
This table right here perfectly categorizes everything we've just learned. Solids are locked in. They have a fixed volume, high density, a definite shape, and zero fluidity. Liquids hold on to that fixed volume and have moderate to high density, but they completely lose the definite shape, which is what allows them to flow. And then you have gases, the ultimate rule benders. Absolutely no fixed volume, low density, they'll expand to fill whatever container you put them in, and they flow effortlessly.
Which leaves us with this final kind of mind-bending thought. We've seen how just the mild warmth of a hand can turn solid gallium into a flowing liquid, and how pressure can completely manipulate gases. If shifting temperature and pressure dictate the state, volume, and shape of every earthly substance we know, what in the world happens to matter under the extreme, unimaginable, literally crushing conditions of a black hole? Does it become a solid, a fluid, or something else entirely? Keep observing the states of matter around you and keep asking those big questions. Thanks for watching.